last video, we were doing this, but unfortunately, I think I got the rate wrong. That's really messed up. This thing actually looks like S of n is 100 plus 100 times 1 plus 0.03. I don't think that I took into account that this thing compounds monthly. Sorry. I know, but I made a mistake. Hey, now. If you put this stuff in your calculator, so that's what our actual rate should be. 1.0025. Sorry. You know, one day I'll be replaced by a computer and there will be no mistakes ever made. To the 11th. Alright. So that's what that should actually look like. Sorry. So if we wanted to calculate what S sub 12 is, we would go 100 times 1 minus 1.0025 to the 12th power, all divided by 1 minus 1.0025. What is that, you say? I know. It is something. Darn it. Hey, let's everybody, if you have a calculator, let's all put this into our calculator together. See if you get the right answer. Because this, when people calculate these in their calculators, they make mistakes a lot. So right off the bat, I want to make sure that you don't make mistakes a lot. Okay? I just did, so it's, you know. So I got approximately 1,216.64. If you didn't get that, I'm going to show you what you should have entered in your calculator. In your calculator, you want to put exactly this. 100 times 1 minus 1.0025 caret 12 close parentheses divided by. You need parentheses for your denominator, or else it follows order of operations and gives you the wrong answer. That's what you need to put in your calculator. Yep. If you put something other than that, you wind up with wrong answer, unless you just add a parentheses. You did it differently? So you got the right answer? Oh. So, okay, so what I was saying is last time, this right here, I did not calculate correctly. I said 1.03 because I had neglected the fact that it's compounding. Yeah, I did put the 12? No, I didn't. Yeah, so I made a mistake. And when you calculate that, you get this. Okay, so that's what happened. Lo siento. Huh? I'm kind of sorry about this one actually. I don't like making mistakes in a recording. It's not a good feeling. I like mistakes that just go away. Like what happened? No, there's no evidence. Okay, ready? There's some information here that's good. I'm actually going to write this down in the next one. So for the sake of the video, if you want to look at this and commit to memory or take a picture of it or whatever, that's fine. I'm going to actually show you this stuff in the next slide. So here we go. Sometimes you get a problem and you're missing some stuff. What's missing? Okay, so our formula has a sub 1 in it. Yeah, it's missing R. It's missing R. Said it twice. That's weird. I am actually a member of the Department of Redundancy Department. Head manager, yes, of the Redundancy Department. Okay. So what we need is to find R. I have a formula that helps me do that. This formula is actually the same for a geometric sequence as it is for a geometric series. If I want to find the nth term of a particular series or sequence, I know that it always looks like this, right? A sub 1 times r to the n minus 1, okay? That's what it looks like. So what this is telling me is that n is equal to 5, right? It also tells me to substitute 81 in right there, okay? So it's telling me the fifth term is 81. And because we know what the fifth term is, we can find out what r is, all right? So we say 81, the fifth term, is equal to a sub 1, which is given. We don't know r, and it told us that n is 5. I'm going to go ahead and solve this. 81 divided by 16
What is that?
is going to be equal to r to the, what's r? 5 minus 1, right? Hey, let's go ahead and take the fourth root of both sides so that we can get rid of that 4. That 4 in the exponent. Fourth root of 81 over 16 equals r. Hey, I can write that as the fourth root of 81 over the fourth root of 16. What is the fourth root of 81? Anyone remember that right offhand? 3. Ah, you guys are awesome. And the fourth root of 16 is 2. So there we go. We know what r is. Now that we know what r is, we can plug r into our handy-dandy geometric series formula and say that s sub 5 is a sub 1 times 1 minus r to the 5th power, right? That's n that goes right there. All divided by 1 minus r. Okay, if we're going to put this in our calculator, I'm going to show you exactly how you want to put it in, okay? 16, parentheses, 1, minus. You got to put that 3/2 in parentheses, caret. 5, close parentheses, divided by. Start a new parenthesis. 1 minus. You got to put the 3/2 in parentheses, and you put that in your calculator. Just like that. I had the weirdest dream last night. I just remembered it. Isn't that weird how that happens? You should get 211. This is all quite good. This stuff on the bottom is not good. This is what I'm gonna do. This 4 tells me, okay, stop at n equals 4. This one tells me, start at n equals 1, okay? This particular sum happens to be a geometric series. They're not always going to be a geometric series. And we're going to get some better examples. I do have a tattoo. Because I do an infinite summation on my... No. But I have written it down.
What sound do
It depends. The stress sound
you like?
or the sound of a mother cuddling her
All the
baby.
videos I've seen. Giraffes never make it. I've never heard them sound.
I think they do. Alright. So let's go ahead and do one, okay? Let's go ahead and write the sum without using summation notation. So this is telling me start with k equals 0. This tells me stop with k equals 5. And all I do is substitute. It's saying, hey, substitute the first number, and then in sequential order, substitute the next one, right? I should say consecutive. Sorry, that was the word I was looking for. That's why I had a little brain moment. Right? Consecutive numbers. So in other words, I plug in k equals 0. And then I add it to k equals 1. And then I add it to k equals 2. I add it to k equals 3. Four. What is the sum of that? It's 15. It's 15. Hey, remember I showed you that, this formula says that this is for an arithmetic series, which is n times a sub 1 plus a sub n over 2. And it's weird for this one because a sub 1, it turns out, is actually 1. It doesn't count to put 0 in there. So if you want it to be fancy, like Johann Gauss, you could do this, right? N is 5, right? A sub 1 is 1, we'll say, because 0 is not good. And 2. If you put that in your handy dandy calculator, or just do it in your mind, because it's 3 times 5, you get 15. You get the same thing. 10. I would never give you a problem where you have to do this, and I haven't given you the. Right. Ready? Oh. Okay, here we go. Firing squad. Let's do this one. Hey, it says start at 5, so j equals 5. And then I'm gonna go all the way to 7. What's wrong with this, boys? You don't like it? Sorry. It was the result of me having a frog in my throat. And then I just went with it. I said, I'll be this guy for a minute. Somebody want to calculate that, guys? 110 pins. That's pretty easy, right? You see what I'm doing? Consecutive integers, plugging in. It tells me start with this one, end with this one, right? Start with 5, end with 7, plug in consecutive integers into j. Add them up. Let's do it again. Let's do it again. Do you need that backup? No? Oh, my slow riders already. I'm not sorry. Okay. Start I equals 2. And then I'm gonna plug it in. I is still 3. And then I'm gonna go all the way up to I equals 4. 2, 3, 4. Okay. All right. Let's 13, 12. Thank you. Beautiful. Yay! Oh. Let's do more. Okay. Hey, let's write each one of these using summation notation. Let's not evaluate the sum. So here we go. Ready? First thing you have to do is I got to write my fancy sigma. And then, what did we start with? It looks like we started with
1.
x equals 1. How far did we go? We went up to 9, right? What does it look like our variable is? We did it. Look at that. We took a sum and we wrote it using summation notation. Look at us go. Hey, we haven't done trig yet. We're going to do it next week. Well, after spring break.
What?
Huh? After spring break, we start trig.
Oh, yes.
I am thinking about... Alright, let's do it again. Okay, it doesn't matter because we can figure this thing out, right? Oh no, we can't. We're not going to do this one. You need to know that. Cosine. What cosine of 0 is. So, another word. Ooh. Oh. Okay, well, I'm going to do the easy part. I'm going to write sigma. I used to do my sigmas all like...
Summation, location, nation.
JK.
Dang, dude, again.
Okay. It's ugly? You don't like it?
Tiny barn.
Anyways, no, I'll show you how to go, Mike. Alright. Let's make it look... You don't have to put little things on it. I don't know why I insist on doing that. I'm avoiding the actual problem. Alright. We're going all the way up to 1,000. So we're going to have to figure out what term this is, right? It looks like we're increasing by 2 every time, right? It seems like possibly this is in arithmetic. No, it's not. It means that it's going to be easier to figure out, right?
Exponential. Power of 2.
Huh? It looks like R is 2, right? So let's just look at this separately before we get into the summation. Huh? Oh, well, hold on. We can find out if it's arithmetic. Let's see. So 4 divided by 2, is that equal to 6 divided by 4? No. So it's not, sorry, it's not a geometric series. I said arithmetic, but it's not a geometric, okay? So we got to figure out what is going on. You're saying the power of 2?
Yeah.
Like 4 squared?
2 squared is 4, 2 cubed equals
2 cubed is not 6.
Yeah.
All right. Huh? Yeah, it is. So it turns out that this is actually 2. Okay. Clearly we're starting at x equals 1. Now our big question mark is, what's 1,000?
500.
Yeah.
500.
We did it. Right. All right. Hey, that wraps that up. We'll work on this to start off tomorrow. This is actually a good segue into park. This is actually a park example problem. This is from park. This is what a example park problem would look like for this one. This is your homework. I will go ahead and get you your geometric series worksheet tomorrow. If you want to get started on that, huh? You guys will have your skill test over this on Friday. If you're not going to be here, you can take it tomorrow. Not tomorrow either? If you're not going to be here tomorrow or Friday, thank you for watching. This has nothing to do with you, video watchers.